Finding the slope between 2 points and then deciding if those lines are parallel. That was the last lesson from Friday for those of you that may have forgotten, since that seems like an eon ago. But that's what we did. We found the slope between 2 points, and if the slopes were the same, then they were parallel. Now, that can be trickier than what it seems. So I give you a couple examples here. Let's say connect A and B, and that's a line, and connect C and D, and that's a line, and let's decide if those are parallel. Well, what's the difference between 5 and 2, the up and down direction, the Y direction, the rise in the slope of A to B, the rise over the run? Well, the rise between 3 is 3, between 5 and 2 is 3, and the run between 2 and -4 is 6. That reduces to 1/2. So that it appears that is the slope of that one. How about here? The rise between your y values is 1, and your run between your x values side to side is 2. There's 2 spaces between -1 and 1. So if you're just purely looking at the numbers and the space in between them, there's 3 spaces between 5 and 2, 3. There's 6 spaces between 2 and -4, 6, you get 1/2. 1 space between the rise 0 and 1, 2 spaces between the 1, -1 and 1, you get 1/2. You'd say, yeah, they're parallel. All right, it's because I wasn't probably clear enough as I should have been in the lesson on Friday. These are actually not parallel. And the only way to really know this is to plot these points. So that's what I want you to do when it comes time to take the test. Is if you get a problem like this that gives you a set of points and asks you, are they parallel, perpendicular, or just plain old intersecting at some random angle, you have to plot the points and connect the points with the line. It's the only way to ensure that you're doing it right. So let me do that. Point A is 2, 5. So over 2, up 5. 1, 2, 3, 4, 5. That's A right there. Hopefully you can see that. And that's kind of small. I think I'm going to have to go back to the board here. So there's A right there. Point B is -4, 2. 1, 2, 3, 4, up 2 right here. So that's B. This was A. All right, if we connect those with a line, it looks something like this. All right, now let's plot C and D and connect those. C is at 1, 0, which is right here. D is at -1, 1, which is right there. So this is C and this is D. Now, if you connect C and D, clearly the lines CD and the lines AB are not parallel. They intersect. So where did we go wrong over here? Why do the numbers seem like they're both 1/2, but when we graph them, they're clearly not parallel? It's because the CD, the line CD, is a -1/2. This line is going down. The rise to get from here to here is 1. You're going up and down 1, and you're going across 2 spaces, so it is 1/2. But the line from left to right is going down, so it's actually -1/2. And that's how slopes work. You look at a line like you're reading, you go from left to right. So from left to right, if this line is going down, it's a negative slope. So lines that go down have a negative slope. Lines that go up from left to right have a positive slope. So even though this looked like it was 1/2, it was actually -1/2, and this was positive 1/2, and therefore they're not parallel. You might look in this and say, this is not 1/2. You're going up more than 1 and over more than 2, which you're right. You're going up 1, 2, 3, and you're going over 1, 2, 3, 4, 5, 6. So that slope is actually 3 over 6. And that's what I had there before I erased it. But remember, you have to reduce your fractions. 3 over 6 is 1/2. So we're comparing a slope of 1/2 compared to a slope of -1/2, and they're not parallel because of that. So that's the important part that I left out on Friday. Sorry. Now you know. So if you struggled with that over the weekend, that was most likely why. But it leads into what I want to show you today, which is how do you tell if lines are perpendicular? All right, and this is usually a lot of people's guess, is that if it has the same slope, but one's positive and one's negative, and you're half right, that is half of it. So for lines to be perpendicular, one of the slopes has to be positive, the other one has to be negative. So we've got that part right. What we don't have right is that they're not the same number, okay? They're the reciprocal of each other. You got to flip that fraction. So for these to be perpendicular, if our first line is 1/2, our second line would have to be negative 2/1, or just negative 2. All right, if our first line has a slope of 3/4, then our second line has to have a slope of negative 4/3. If our first line has a slope of 5/7, then our next line has to have a slope of negative 7/5. So one has to be positive, one has to be negative, and they have to be reciprocals. You have to flip that fraction. So we were close. These were almost perpendicular. You could probably tell just by looking at them that that's not a right angle right there. But we were halfway there. We just had to flip that fraction, so they're not quite perpendicular. And most lines that cross are not perpendicular. They cross at any other degree angle, 89, 88, 87, 86. It has to be exactly 90 degrees. So if they cross, that means they're not parallel because they crossed. They're probably not perpendicular unless they cross real specifically. They're just called intersecting or skew. All right, just a regular old intersecting line, nothing special about it. For intersecting lines to be special, their slopes have to be the opposite or the negative reciprocals, it's called. Flip the fraction, one's positive, one line's going up, one line's going down. Right? So that leads into the work for today, which is going to be very similar to the work from Friday and Thursday. So the work from Friday was just points. You just had points and you had to decide if they were parallel. Well, now you just have points and you have to decide if they're perpendicular. So let's do an example. Are these lines perpendicular? The line that connects A and B compared to the line that connects C and D, are they perpendicular? Well, like I'm going to stress to you to please graph these points, I'm going to graph them. So line A to B is from 2, 0 to 0, 6. So it looks like that. And line 2 goes from 1, 0 to 4, -1. Looks like this. So you can kind of tell just by looking at them that they're probably not perpendicular, but you have to check the slopes. You can't just go by the eye test. So for the first line, 2, 0 and 0, 6, you are going up 6 spaces and over 2, so that's 6/2, which reduces to 3/1, and the line is going down. So it's a negative 3/1. So for these to be perpendicular, this slope would have to be a positive 1/3. So how far down are we going to get from 0 to -1? We're going down 1 space, and we're going over 3 spaces to get from 1 to 4. So 1/3, ooh, that looks good. That's what we want. But this line is also going down. So this is negative 3/1. This is negative 1/3. So this is kind of the opposite of the last example I showed you where we had half of it. One was positive, one was negative, but the fractions were not flipped. Now we have the fractions are flipped, but they're both negative. So no, they're not perpendicular. You have to have both. You have to have the signs being opposite, one positive, one negative, and you have to have your fractions being flipped. You have to have both. If you only have one of the two criteria, they're not perpendicular. So this is a big no. Not perpendicular. They cross. They're clearly not parallel. They don't have the same slopes. They're just regular old intersecting lines. That's it. Okay, so that's the first set of problems in the do section today. You're given 2 points from 2 different lines, you plot them, you find their slopes, and you say whether or not they're perpendicular. The next part is what we did on Thursday, which is you're going to be given 2 equations, and you have to say whether those equations are perpendicular. So here's one equation. 4y plus 3x equals 6. And we want to know, is that perpendicular to this equation, which would be 6x, or I'm sorry, yeah, let's do that. 6x minus 8y is equal to 10. All right, are those 2 lines perpendicular? Well, to figure out what the slope of an equation is, you have to get it in slope-intercept form. You have to have y all by itself. So to get y all by itself on the first one, you subtract 3x to the other side, and you divide by 4, and you get negative 3 over 4x. So the slope of the first line is negative 3/4. How about the slope of the second one? You subtract your 6 to the other side, so you get negative 8y is equal to 10 minus 6x, and then you divide by negative 8. So when you divide by negative 8, we're not worried about the y-intercept right now. You get a negative divided by a negative, which is a positive, so you're actually positive 6 over 8x, which reduces to positive 3/4. So no, not quite. They're not quite perpendicular. Yes, one is negative, one is positive, but they're not reciprocals. We did not flip them. They're both 3/4. So no, they're not perpendicular. All right, so you've had practice at this. All it is getting y by itself. You're going to have to do that. You're going to be given equations that aren't in slope-intercept form, and you're going to have to put them into slope-intercept form by getting y by itself, and then compare the slopes. Are they exactly the same? They're parallel. Are they negative reciprocals? Is one positive and one negative, and you flip them? If so, then they're perpendicular. But if they're not either of those two things, if they're not exactly the same, or they're not negative reciprocals, then they're just regular old intersecting lines. And that's what we have here, regular old intersecting lines. They're not parallel or perpendicular. All right, I'm going to do something a little bit different today. Instead of just listing all of your problems in the do section, I'm giving you 3 problems at the end of the watch section. And this will be my little test to see who's watching my wonderful videos from start to finish. So along with the 4 problems in the book that are in the do section, I also want you to do these 3 problems. All right, so they all have the same directions. Write the slope of each line, which is the example I gave you earlier. You plot these A and B, you connect them, and you say what the slope is. You plot C and D, you connect them, you say what the slope is. And are those slopes perpendicular to each other? Are they reciprocals and one negative is one positive? Either a yes or a no. Same direction here, same direction there. So 3 more problems on top of the 4 in the do section. So make sure you're doing all 7 or you're busted. Thanks.